And I think I turned it on, so yeah, you can hear me very well, even over somewhere else. So I will talk about test-driven development for Arduino. I'll start a little bit with talking about myself. I was studying computer science at University, and then I got work at a consulting company here in town called Open Software. I was thinking they had a cool name, and then they called a company called Haiku. And they didn't was that much open source for open software, so I was a little, it had to do with other things, the history of the name. Long before the open source ID was open source, the name was older than that. And then, now 6 years ago, I moved from Haiku and consultancy, mostly for Ericsson, to a company called Mikkel, where I work close to the car industry. I was employed as Linux expert. That's my role there. So I work with embedded systems most of the time. And as part of one of my educations, I was moving closer to hardware this year. And one of the things I know from development, I think agile programming is very good. And this test-driven development is one of the cornerstones of agile development. And many people working in embedded world things, many people working in open source world that don't think we can use agile methods in this kind of projects. But I think at least the test-driven development part is really suited for taking into both embedded programming and open source development. Because it's very clear what you're trying to do and why you're trying to do it. And one of the misunderstandings is that test-driven development has to do with regression testing. It has nothing to do with regression testing. It's a development method. You don't do it to test your stuff, you make it to develop your stuff. And you start the development by making test cases instead of ending your development making test cases. Usually when you... The idea is that you start making test cases, is that you start making code that uses your code. That's the idea. And then you have a better idea of what code you're trying to do. And that's the most important thing, I think, you should take from my idea of programming into. So. When you do testing, what part of the system can you trust? When I develop for the Arduino, I can trust that the functions in the Arduino is, or library, if I do a digital write or a pin, I can trust that it actually works. You don't have to verify that. I can say that. So I can take those functions out and don't have to do them in my test environment. They only need to be done on the target. I can mock away all of the fake objects that I make my code much quicker. I can do the same thing if I have a hardware that have a memory interface. Where I have direct access to memory, MAC address. I can do the same thing I can assume that the hardware works. When I write software, I assume the hardware works. It's not always the case, but I can assume it at least. If I know I go right, but the hardware should be working, I am in a much better position also to complain about the hardware not working. I have tested it and know that it does. But I think it's doing the code above it. So that's why I'm using test-driven development. And I was quick in there, mock objects. I use a lot of mock objects. I'm working object-oriented when I program the Arduino. The Arduino has a nice IDE that is all but it's a nice way to hide that it is C++. but Arduino is plain C++. The Eno files are C++ file where they have taken away the include Arduino.h on the top. That's all the difference between C++ and Arduino. And they also have given a small main file for you. That's first call setup, so they'll have a loop that calls a loop function. That's all there is. That is C++. Like, the main function is very simple. And there are two versions here. There's mock objects and there are fake objects. Mock objects, just tell them you expect something to happen on them. Fake objects, you don't have that part if they are just taking the course. I'm usually mostly using mock objects, and I'm using code from Google called Google Mock to make them quite easy. Test-driven development is going around some development steps. First you have a ready state, that is make something fail. You have the green state to make that one test pass as quick as possible. And the refactory step where you make it look good. And you can have this loop on many levels. You can have it on the acceptance test level, and then a loop through this can take months or at least weeks. You have it on the unit smallest level, and then a good loop takes 1 or 2 minutes, going through all of these steps. Make a test that fails, make it pass, make it look better. We actually have one step before outside this also is to select what are you trying to do. That's somewhere before the red step. What will the next part of this trying to do? But this is the mantra part. This is what you do all the time. You have a bigger loop with more things in it. The tools I'm using for development, I of course have the Arduino, IDE and SDK. I mostly use the SDK part with the working compiler and some stuff from that. I don't use a IDE myself. I use Google Test. I think that is the best unit test framework at the moment for C++. It's quite easy to use. You don't have to work. If you have used unit test, you have to specify a header file and a lot of things. In Google Test, you just write this is a test, and then you run it. So it's very little overhead. Google Mock, I said there, it's a way to make, from an interface file, it makes all the files around that you get the expect. And I made a Google Mock framework for the Arduino interface, so I can mock the calls to digital write and digital read, or analog write and manual read. And then I use CMake as my, I shouldn't say build system choice, because CMake is a meta build system. So it creates make files or IDE environments or something like that, so each developer can use whatever tool they like. It has support for ClueMake output, it has support for Eclipse, Xcode, Visual Studio, or a lot of other things. And it's a very good way to just put in what you need in the what files are included and how they depend on each other, and they figure out the rest. Because it's installed on computer, it knows what you have for development environment, so I don't have to specify that. I don't have to specify what compilers I have, because it's installed on my computer, so it figures that out. There's a little extra part I have to tell it about that I have when I use the Arduino in some case. The game of life I was planning to do here for you. It's an automata game, mathematical, from the 1970s. And it's playing out in a two-dimensional memory array. And the rules are that a live cell with fewer than 2 live neighbors dies from underpopulation. Live cell with 2 or 3 neighbors will continue to live on. Live cell with more than 3 live neighbors dies overcrowding. And a dead cell with exactly 3 neighbors will spawn to life. So that is the parts of the rules. My program, I will use time functionality, so I can tick each new generation every second, and I can update the LED metrics display every 10 milliseconds. I have a hardware driver that actually drives the hardware I'm interested in, this LED display, LED metrics. And I have directly driven it from the Arduino, and that's now it's the absolute simplest way to do that. And of course I need something to drive the game matrix. I don't know if you know about what the LED matrix is. There's a lot of LEDs connected into the Arduino here. Oh, it's flickering. But each, you turn the power on one row, and then you turn the powers on the columns as you like them to light, and then to the next row and next row, so all the time. So each time you look through all this one fast enough that the eye thinks they are all at the same time light up. And it works so if the row, you turn that one high, and each column you want to show, you turn that one low. And you forget the potential between them to actually get the light LED to show up. This is a very simple one, so I have put one resistor on each row, and that will, like if you turn on all the LEDs, it might be a little different in the light than if you turn just individual. So it's the simplest way to do it. Maybe not the best, the simplest. So I will write a driver for this one, and the code is up on GitHub, where I have my personal stuff since many years. Now we shall see if we can get this one working. So, there, and some code. Okay. So this is the main file for CMake. I will not go through all the details. We have a lot of bad looking stuff here because Windows actually sucks very bad. And I had started this project as education on work, and they are not smart enough to use Windows to Linux machines. So I had to have this extra bad stuff to actually change how you should do the works when I use Windows. So CMake, you have here, you tell it that they have an executable, what files is needed for that executable, and what libraries it needs to link with, and this is the Google test environment, Google mock environment, and the main file from Google test. So this is a unit test only. And also you tell it that this is a test you want to run. And then I just run that inside here. And it will start up everything, run the test, and see everything passed. Yay. This is actually the timer class. I took that one from my bot project, moved into here. We have a start point. And what we're doing to know, we should add another executable. So I'm finding that LED driver test maybe, testing LED driver. LED driver.h, you can call it, and we need a test code for that. And I have separated always my test code from the target code using different libraries in different directories. I had the underscore there before, so let's call it the same. We need to use this stub out Arduino environment. Because I want to check that this one actually does call the...
Did you miss the name, the extension CCC? Should be CPP first?
Yeah, of course. That's why we always pair program. So we have a new binary. We also need to make sure we need to link it with some thing. Test. Yes, running. So that's a the CMake part does look quite okay. If we try to make and compile this one now, it will complain badly because it doesn't have the size that's expected. So we make them. We need to page. This is a hard part about C++. There's a lot of typing in C++. So, and we also need the test code, huh? And that one could be quite. That's a good start for test. And now I think we should have something that compiles, works. And we didn't. Or we have done something wrong somewhere. Yeah, it's and test there. It's not executable, of course. Here. As an executable, we should have test there. So, on that. And we have a first working test for that one. We didn't run it. Something. Yeah, name here. Oops. So, actually make 2 tests, roll pop. Yay! Good start. We have a very simple test case and it works. We maybe should make a little more complex case. Do you see good what I'm typing?
Yep.
Yep. And to make that, we need to include something. Plus. Change my. We need to have the file for the test system, test framework, and could be good to take in the bed driver as well. Like that. And then a test with Google Test starts like this. You need a name for the test suite. The only downside with this framework is you can't have spaces or underscores, or they don't recommend it. You should have this, and sometimes it's harder to write. And the first test I'm doing is the simplest part of this. Is I don't know if you remember but the first thing you should do is you should turn on the first row on the LED matrix. So, we need a display function, I think that should do this, and we test this one. Yeah, on it. That's the reason for this one is that this explains all the test case for me, and I don't have to do any documentation. But when I read that one, I know what I'm testing, so I don't need any documentation of this. It's better to have a function name doing it at this level. There are other cases when function name shouldn't be this level. I think it's good here, and we need some kind of LED driver, and we need the mocked environment for Arduino. I got it back out. And also as we work, I have to release it on the end, so I know when it's finished. That's that one. And I need my new LED driver. That has to be something like that. And then I wanted to set up now and tell the framework here what I wanted to do. This is working with the mock object. And I want to expect, when I do the show, this is a part of the mock object, I actually tell it before I call it what I expect it to show. And I expect this Arduino mock that they should get a big towel. Right? And this is part of the Arduino interface. I don't know if you're familiar with it. And I need to know what row it should write on. And I have that in my hardware chain. I think it's 13, the first row. And it should go high. So I expect that one to happen when I, whoops, let's see, yeah. And also, and I expect it to be called one time. This is part of the Google mock, Google test framework things that are working together. And then I do this LED driver dot. We think display, it's a good name. Show. We do. Right? Or maybe display. Something like that. Does that work? That's a useful way to do. I should be able to do this. Now we have the setup part, we have the test part, and we have a teardown part of the test. So we set it up, what we expect to happen, here we do the actual test, and here we have the teardown, release the memory or whatever. And so I think that could work. Arnholm, no, not one. We have our test code. So at this stage, I don't think we can compile this because I haven't made the LED driver class yet. So we need some of the nice part of C++, typing. And the only thing we had here was the void display function. Anything, and we make the absolute most possible simple solution for implementing that one. That will work. So, whoops. I think we have something that compiles. Now the first, we're on the red step here. I think this will fail because we don't call the digital write function. That's my expectation. When I run this test, it will fail because I don't call the function that is supposed to be called, digital write. So we test that one. What happened? And it fails because something is very wrong with my code somewhere. I haven't included something. I don't have the Arduino mock function. So, that's all nice. Ah, don't include the magic Arduino.h. All Arduino code needs this one. Include. So, that probably will compile. Not that much. Yeah. Another feature. Spell it wrong. Yeah. Oh, okay. That's a bug part of C++, lots of things to say. What we expected, I called this data write 13 and high, and it didn't do it. So it actually did exactly what I expected. This is the test failure I was waiting for. And because we are in that test failure I was waiting for, I could go over to the next step in this test-driven development. So now we are in green phase. Now I want to make this pass. And we take out the code here. And the absolute simplest possible solution ever to make this pass is what we are trying to do. Just this test, don't look forward. And I think if we just do a digital write on the ping we need, and make that high, I think we should have something passing. Do you think this will pass? Do you think this is what we need to make this one green? Yeah, so let's test it. It's important also that you actually do this testing every time. And you don't have high. Boy, that wasn't what I expected. I know why. Because I even here forget include so now I expect it to be green. And it is green. So next step I do in all this is the refactoring part. And when I look at this code, I see I have some magic numbers. And then now the number 13 is shared with the actual code and test code. And I always see both the test code and the code as one unit. It's one program. You can't separate test code from real code. It's one program. And it's part of this. So I need to refactor. And do the LED driver need to know what pin actually? Should it be a part of that LED driver or should it be part of the environment? We are in design decision here. If the LED driver should work with any setup of pins or and control at setup time, or if it's something that is hard coded for my driver. And it could vary between what project I'm doing. I think in this case, I'll do it here. Row 13. Has to know about it. And then when I do the setup here, I tell it what pins we should be using. So, and then I need it here, so I need a constructor. That. Let's save that before we save it. You're not telling me when I type something wrong. Come on. You think I know what I'm doing? This is my convention here. That I've been before. All member, all feedback that we are using the prefix for. Something like that. Here. Do you think that will work? Seems a quite simple, easy refactoring. You shouldn't change anything, so I can run my test again. Didn't work. No, because I can't type. It's probably to tell me when I can't type. That, maybe. Oh, seems I forgot to say something. So we are going to through the refactoring part. And what is the next step now? Go back on red. So we do another test here. And do we have any ideas what we maybe want to be testing next? Well, if you look at the hardware diagram, we should also turn the columns high because from the start we should have everything turned off. So the pin for the first column should also be high. So that's another test. Yes. So I'll probably type a little less. The drive function should after first call turn off. Column 1. And I don't remember, but I think that this one is the PM, so let's say it's number 4. Doesn't have that much importance for this part of the testing. I look it up on my hardware machine. Let's guess it was number 4. So still have the same setup, and it should turn the first column pin higher. Push it off. Yeah, looks good. Think it will work. My expected outcome now is that the test fails because it didn't always turn the 4th pin on. That's my expectation. It should be dead, red, fail with that error. And it looks like it did that, even though, yeah, it says here it's called the 13, yeah, 1, and then, no, it doesn't match here. So it's not the best error message, but it's trying to tell you what it got in. So it's actually, yeah, we got a call to digital right 4.1. So we didn't get that call we were expecting. we did get another call there, 13 high. And that's something we didn't expect that one, but we probably should have expected that we have some call to not 4 with any number. And to have this work, we have to tell the framework here, use test not, and also the underscore. And usually I always forget these 2 lines with strange compile errors. So we want an extra, something else you call let fail, still that test. And inspected the 4.1, 4.5 we call 1 time. That's only the thing we didn't get. But the other pins, they are okay. We are only testing one of the pins here. We just keep the test as simple as possible. So that failed as we expected it. So we go over to the read. And now we need here, we want to do the other column. Number 4, we want to turn that one on as well. Do you think this will work? Yeah. So, let's test it. And actually, it did work, but now our other test failed. So, is that we didn't think about everything when we wrote the first test, or is it something else? Yes, I would say we forgot something when we wrote that test, because we're here checking all the calls to this mock by default. There is a possibility to turn moving mock over, so unexpected calls is passed, but the default is that everything that you're not expecting is a failure. I think that's a good move. So I try to keep on, and then I need to move this one up here. And I need something very similar to that one, but the 13 is dead, and it's not actually 13 because it's this one. Something not on row, anything is okay. And another thing also, I have expecting it here to be called 1 time. times 1. And that's probably not right. Could be any time. And that's also one of these special keywords that I need to import. Now hopefully I remember everything. Go. No, because not many times. Time. I think it is. So. No. Silly me. Any number of times the function can be called. Ah! Right. So we are passing out into the factor state. And I think we have two things here I don't like about the code. We have a 4 there for the pin. That can we do very similar to this one. So I think that will work. Close the factoring. Yes, it works. And also we should tell the test case that it actually wants it to use the number, or same way as here. Anyone know the auto typing C++ editor that use your brain? Okay, one. So, and we need to make sure we actually use it here. And now we're starting to feel I have something more wrong, because I have to fix that call 2 places. So there's something more wrong in this code that needs to remember for refactoring. We are in the refactoring stage, so I'm allowed to think about refactoring and making the code better. But first we make this one clear, test it. It worked, good. And now as you also see here, I had to fix this one in 2 places, so probably I have something wrong in my code. I want a setup function. So I don't have to do this. Yeah?
I see a magic number as well. Right?
Where?
Digits are right 4 high.
Yeah. Good. Good spotted.
Yeah, you can't program.
Good spotted. I got the new nice variable here to use. But I didn't do it. That's good. Good spot. So we have to test it again. Well, we have a quick test you can do it on. Also, you have to make this one probably into smaller testing framework, so you just test this part and you can run part of it, because when you get bigger projects, the testing will take time. So, for that part. And also I see the setup part now, I do that refactoring here. Now I will show you some more of the magic from Google Test. And I have a name for my test places here. They were test 10. Cool. I was thinking I had that one. So I make just a class for it. And the semicolon. From B. Also forget it. And you can, when it's set up tests here, you can either use a constructor for the class or a function called setup. Decide yourself. We'll do the constructor today. So I need the default constructor. That's a simple one. Very simple default constructor. And here comes a little thing you have to remember. When you have a setup class, you're not longer using test, you're using the test F. That's because the guys writing this framework wasn't able. The test macro creates a class, but the test F macro creates a class that is depending on another class, and they couldn't make that macro as good as they wanted. So, yeah. So now we are using that setup function. We are part of this, and that's refactoring the second test for itself, and that didn't work. Yeah, I know why. I still test TED driver. Didn't make it test. TED driver. Makes sense when you see it. And as always with C++ and macros, the error messages are sometimes strange. And this one, because I just made a class here, I forgot something important. This one needs to be part of the test framework, of course. It has to be testing. All of the Google test things are in the testing interface. And the test cases are called test. I think I should say it before. I think I know how to say it in this section. And I'm not awake. Are you awake? Sure. So, that looks more simple. Yeah, and we're still in the same situation. It works, kind of. We still have this duplicated code here. And this Arduino mock, both test cases use it. So I know it's up here. And then I need to this. That. That one. No? On that one here. And we also have this LED driver. That is used in both cases. This is actually hard. Do I have the variable there? Yes. So, I think we are past that refactoring as well, and then we go back to next step and the 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 next step, and maybe the next step after that. And when you're all done, oh, stick on things. Well, I have prepared it anyhow. So, this is the finished code. I think that's it.